Colloids. So colloids are also called colloidal dispersions. These are mixtures in which what you can think of as the solute, whatever's dispersed in the liquid, is just finely divided in the dispersing medium. So the colloidal particles are small enough to stay suspended, but they're larger than typical molecules. So typically they'll be a nanometer to 1,000 nanometers in diameter. And the result of that is a colloidal dispersion will appear cloudy because the particles that are suspended in there are large enough to affect the light transmission. If you look under a microscope, you can see the colloidal particles moving. It's called Brownian motion. It's caused by collisions with molecules in the liquid. Let's see if I can get this to work.
Michael's Black Friday sale is going on now. Get 70% off frames, ribbon, and more. Up to 60% off trees, decor, and ornaments. Plus, epic deals on thousands of items in store and online. Hurry, sale ends November 27th.
Well, at least thank you for the train for some of that. We saw this video before, but so these are the little pollen grains that are forming a colloid, and you can see them jiggling around. They're big enough you can see them on a microscope. Why are they jiggling around? They're jiggling because water molecules are bumping them. So we see the movement of the colloidal particle, but the water molecules are too small to see. So this can happen with a soap solution. When you put soap into water, the soap molecules can form micelles. So this is an illustration of a micelle. So the soap molecules have this long hydrocarbon chain, just nonpolar carbons and hydrogens, and then at the end here, it's going to have a couple of oxygens, and so this part is actually ionic. It's an ionic head, and so the sodium can come off, and then we have a negative charge here. So these will kind of circle the wagons, right? So they'll circle around so that all of these nonpolar tails can be together because they speak the same language, right? They have the same kind of intermolecular forces. And the ionic heads are going to be on the outside because they are in the water. And the water is very polar. And so it's the ionic heads of the soap molecules that can relate to the water molecules. And then we've got some electrostatic repulsions between these, which keep them from just forming their own thing like oil does. And then these micelles function to remove dirt and grease because grease and oily things are not soluble in water, but they are soluble in this interior part of the micelle. And then the micelle is free to flow away with the water. Other very large molecules like proteins will also form colloids. So there's a cloudiness. You can try this at home. Take some water, put a couple squirts of soap in it and stir it up. It's going to appear a little bit cloudy. But that's because of the micelles that form from the soap molecules. There are a lot of different colloidal dispersions. Here's one we've all experienced, fog, right? That's a dispersion of water droplets in the air. So the water droplets are large enough that they affect the light, but they're small enough that they don't fall down like rain. Smoke. is a solid dispersed in a gas. Whipped cream, yum, looking forward to having some of that on my pumpkin pie tomorrow. That's a gas, air bubbles, dispersed in a liquid, butterfat. Milk is a dispersion. It's called an emulsion. So you have the fat globules of the milk in water. So you may have noticed that skim milk somehow looks kind of thin compared to 2% or whole milk, right? That's because there's less fat in it. And it's the fat that gives it that white color that you can't see through. And then an opal is actually an emulsion of, or a dispersion of water inside of silica glass. So here we have a flashlight shining a beam of light through these two solutions. In one of them, we can see where the beam of light is going, and in the other, we can't. This is a true solution. The particles here are too small to scatter light. This one, although it does appear to be transparent, is actually a colloid, because when you shine a bright light on it, it's the little particles scatter the light. And this is the same effect that allows you to see the sun rays coming into a building, right? What that means is you've got a lot of dust in the air. If your air was really, really clean, you wouldn't see the sun streaming in the windows. Any questions?